Let's start by looking at some of these problems that you had for the worksheet for tonight. Okay? Here we're asked to find the area of each of these regular polygons. Well, let's look at number 11. It is an equilateral triangle because it's a regular polygon, so all sides are equal. So, do I find the area as a regular polygon or as an equilateral triangle? Makes no difference. Frankly, it's going to be easier to find the area as an equilateral triangle. So let's look at that. We draw our height. We know that the angle here is 60. Okay, we know that the side here is the side opposite 30, so it's half the hypotenuse. And we know that the height is 4 root 3. So we have everything we need. As the area of a triangle, area is 1/2 the height times the base, which is 1/2 of 4 root 3 times the base, which is 8. We take half of the 4 or half of the 8, not 1/2 of both. So half would give us 16 root 3. That's our answer. Let's look at another problem. Let's look at problem number 13. Problem number 13 gives us the radius of the square as 6. The radius of the square is 6. Again, the square is a regular polygon, but it's also a square. And of course, as a square, the area is equal to side squared. So we could either go and find the apothem and the perimeter and find the area that way, or we could treat it as the square and go back to problems we had before and look at that as the diagonal of the square, which of course would be 12, double the 6, and knowing that that would be a 45, 45, 90, we know that we are looking to find the length of the side here, okay, and that side is 12 divided by root 2. Of course, we know 12 divided by root 2 needs to be rationalized by multiplying by root 2 over root 2, which becomes 12 root 2 over 2, or 6 root 2. So we know that the side is equal to 6 root 2. And we know that the area is equal to the side squared, so it's 6 root 2 squared, which is 36 times root 4, but we're never going to leave it as root 4. So it's 36 times 2, which of course is 72 units. So our area for that guy is 72. So far, okay, it appears as if, okay, our problems with a square and with a equilateral triangle we can find the area by the formulas we used previously. Okay? Now let's look at number 16 per se. 16 is giving us the radius. So the radius of the polygon is 6 root 3. However, for the polygon, we need the apothem, which we don't have. We also need the perimeter, which we don't have. And we also need the side to find the perimeter. So we don't really have much, okay? But in essence, let's see. If we're given the radius of the polygon, we know the radius of polygon is given right there, okay? We'll take another radius of the polygon, given right there, and we know that the triangle now is equilateral. So the triangle being equilateral, we know that the side is 6 root 3 because all sides are equal. And since we know the side is 6 root 3, and we know we have 6 sides, we know that the perimeter is 36 root 3. So now the only thing that remains is the apothem. So let's look at that equilateral triangle that we have. I'm going to enlarge it over here and take a look at it, okay? And look and see how we can find the apothem from there, okay? So we have the apothem, which is going to be this segment right here, which is going to be, okay, opposites is 60. We have, okay, for this triangle, this right triangle here, we have the hypotenuse, which is 6 root 3. Therefore, the side opposite to 30 would be 3 root 3. And the side here, which we're after, would be the side opposite to 60, which would be the small side, 3 root 3 times root 3. We should make that 3 times root 9, but that you know better than to leave that is 3 times 3, which is 9. So now we have our apothem. Our apothem is 9. And we have everything we need because we know the formula. Area is 1/2 the apothem, which we just found was 9, times the perimeter, which we said was 36 root 3. I'm going to take half of the 36, call it 18, so I have 9 times 18, the root of 3, okay, and 9 times 18, I bet is, well, 9 times 9 is 81, so that times 2 is 162 radical 3, okay, and there you have it, all right, so there's a couple examples for finding the area of those regular polygons, 2 of which we found using area formulas from figures we already knew, okay? The others, attack them the same way, okay? Use the same ideas. Remember your formula, 1/2 the apothem times the perimeter. Remember the formulas for triangles and squares, and you should be able to fare okay with that. Okay, good luck. Get them done so you're ready for the quiz.